Assalamu alaikum boys and girls. Now today we are going to discuss the MCQs of the chapter kinematics, in which we have a question uh, which is about the um, motion of a body. A body is has a translative motion if it moves along a. Now how can we say which motion is that? A translative motion is that motion that move in a straight line and without a rotation from here or to here. It doesn't do that. Okay, then such type of rotation is not called translative motion if it rotates. And if it is rotating like this or basically spinning around like this, then it is also not a basically translative motion. So translative motion is that motion which moves in a straight line but without any rotation. So option C is the right answer for the first case. Moving on to the next question, which says, let me clear that out a little bit. It says a body or motion of a body about an axis is called. Now let's consider a body in a circular motion. Now this is a circle and the body is moving about a point. Let's say that is the point which a body is rotating about or circulating about, not rotating. So there's a clear cut definition of circulation, that in case of circulation it has to basically move around a body. But over here he's asking the motion of a body about axis. Now in this case we have to assume that this is the body and it is basically spinning or rotating about an axis, and that is why we are going to choose option B in this case, that it is a rotatory motion rather than a circular motion in this case. So option B is the right answer. Let me figure that out. Option B. Now moving on towards the next question, in which he says, which of the following is a vector quantity? Now, as we have learned the definition, a vector quantity is that quantity which basically has a direction as well as magnitude. Now, speed basically is a scalar quantity because it doesn't have any direction. It can go in this way, this way, this way, in many directions. But the definition demands a vector quantity. So there's a key word over here, which is a vector quantity. Distance also is a scalar quantity. So these both are wrong. So that is why we are not choosing these, because they both are not representing a vector over here. Displacement. Displacement, the definition says the shortest distance between 2 points. So there is a direction between these 2 points, that is from point A to point B. So that is why we can say this is a vector quantity. So I'm taking that as an option but not giving the answer right now. Power. Power is the definition is basically work done per unit time. So over here, power in which direction we don't know, but there's a power. So if we want a direction, we must have a vector quantity in it. So that is why we are now choosing the only quantity which has a vector quantity and a direction, which is displacement. So option C is the right answer. Moving on to the next question. If an object is moving with a constant speed, then its distance time graph will be a straight line. So how can we get to the right answer in this question? Let us draw a graph, and on the x-axis we have time, on the y-axis we have, let's say, distance. Now in this case he says the straight line, there's a constant speed. We have to mention constant speed. The key word here is constant speed, and we have to draw a straight line. If we draw a straight line like this, then our answer will be wrong, because if this line is drawn, it is also straight line, but this line will say that the body is um, at one position at all time. That means at, let's say, over here the displacement is 1 meter, or the distance 1 meter. At after, let's say, over here 2 seconds have passed and the distance is still 1 meter. So has the body moved? No, the body has not moved in this case. So we'll say that the body is at rest. So the question is demanding the speed part. Now how can we represent this whole thing? Again, I'm drawing the time and displacement graph over here. Now the line is a straight line but is in inclined to the time, now time axis. So this inclination shows that when the time was 1 second, the distance was 1 meter, let's say over here. Similarly, when the time was 2 seconds, the displacement or distance was, let's say, 2 meters, like this, and so on. So this line, basically this graph, is representing the incline to the timeline, and that is why our answer should be, and it is, option D. Yes. Moving on towards the next question, which says a straight line, which is quite um, similar to the question which we have done above. A straight line parallel to the time axis on the distance time graph tells that the object is. Now we have option moving with the constant speed, which we have done earlier, at rest moving with the variable speed, in motion. Now in this case, let's draw again the time and displacement graph, and he says that now the line has to be parallel, and parallel word is key word over here. Now if it is parallel to the timeline, then as we have discussed earlier, that after 2 seconds, let's say in 2 seconds, the distance is how much, let's say 1 meter. At 3 seconds, let's say over here, the distance is how much, again 1 meter. That means the body isn't moving with respect to time, or isn't changing its position with respect to its surrounding. So what do we call that body which isn't changing its position with respect to time, or basically with respect to other things? That is a body which is at rest. So option B is the right answer. Moving on towards the eighth question, which says, or you can say fourth question, we can say, by dividing the displacement of a moving body with time we obtain. Now in this case, uh, we have to understand the definition of it first. Speed is equal to distance over time. Now in this case, we have to divide the displacement, not distance. So again, this formula is for the scalar quantities. Now we have to understand the difference between scalar and vector. So vector is basically the those quantities which have direction. So velocity is a vector quantity which has a certain direction, and displacement is a vector quantity as well. So we will divide displacement by time to get velocity, and in that case we can answer this question rightly, that by dividing displacement of a moving body with time, we obtain what? We obtain velocity, not speed. So most of you basically got confused in this one. So I hope you got the answer right in this case. So velocity is the right answer in this one as well. Moving on to the next question, a ball is thrown vertically upwards. Its velocity at the highest point is. Now, in this case, let us explain how the answer comes into play. If you are considering the ball is moving up and then at the highest point, this is the highest point, let's say highest point. Now, at the highest point, what will be its velocity? Because over here in the starting point, let's say its velocity was 19.6 meter per second. But at the top, when it reaches to the top, its velocity becomes zero, because now at the maximum height, it will change its direction and try to come back towards the earth. So at the highest point, its velocity becomes what? Its velocity becomes zero because it has to turn back. So that is why we have chosen the right answer, which is 0 meters per second, because at the highest point the velocity becomes 0. Now for the next question, a change in position is called. Let's say this is point A and this is point B, and a body is moving from point A to point B, and you can say it like that, the shortest distance between these 2 points is known as displacement, and that is also known as a change in position from point A to point B. But it cannot be said as speed, it cannot be said as velocity. So there is a confusion between the displacement and distance. So distance is also there, and that is a change in position as well. But we are talking about the only change in position. That means if it was moving from here to here, then only we are only taking 2 points, and that 2 points basically are the shortest distance between themselves, and that is how we can represent them as a displacement in this case. So we are choosing the option displacement because that is the shortest distance between 2 points. Now this case, the car starts from rest. Now there's a very interesting question over here. It is starting from rest. This is the keyword over here. That means vi is 0. That tells us something. vi is 0 meter per second, and the speed and acquires the speed of 25 meter per second. That means vf is 25 meter per second, and the time is given to us. Time is how much? 20 seconds. Now in this case, the distance moved, we have to calculate the distance moved. Now in this case, uh, most of the students basically, or me as well, will can confuse and write down the formula v is equal to d over t, or we can say s over t, if we can say s is a displacement or something like that, because it's a vector quantity. And we put down the value that if we want to find out the value of d, let's say d will be equal to v into t, and put in the values of v, which is 25 multiplied by 20, the answer will come 500 meters, which is totally wrong, because this is the average velocity, which if we want to take it in that sense, that is the wrong answer. So what do we do from here? We have to calculate the basically distance. For this, we'll use over here the second equation of motion, s is equal to vi into t plus half at squared. So as we know, in the question, it is given that initial velocity is at rest. So s will be equal to 0, because this whole thing becomes 0. So it will multiply by t, it will also become 0. So the thing which is left, which is half into at squared. Let me clear that out a little bit and write it again so that you can understand it very clearly. So here I'm writing it down again. S is equal to vi into t plus half at squared. So as we know that this whole thing becomes 0, because the question said that the body starts from rest. So S will be equal to 0 plus 1 over 2 at squared. So S will be equal to half into at squared. But in this case, we don't have A. How can we calculate A now in this case? For that, we have a VF, which is 25. We have Vi, which is 0, and we have T, which is 20 seconds. From that, we can calculate A. From the first equation in motion, we said Vf minus Vi divided by T. Putting in the values, A will be equal to Vf, which is 20, minus Vi, which is 0, divided by 20 T. So our answer will become 1.25 meter per second square. Putting this value of A in this equation, what do we get? We'll get S is equal to 1 over 2 into 1.25 multiplied by 20 whole square. What is the answer? Answer will become 25, sorry, not 25, 250 meters. And that is our answer, 250 meters. So clearing this all up, let us clear this all up, and our answer will become 25 meters now. Moving on towards the next question, which says, and this is a very confusing question as well, which says that the speed time graph of a car is shown in figure. Which of the following is true? Now you have to understand that they are asking for the true part. Now, most of the question is right in some sense. Most of the question answers are right in some sense, but we have to give the most accurate answer to the question. Now, look at the graph first. The velocity is on the y-axis and the time is on the x-axis. And the initial velocity over here is 15. So Vi is 15 meter per second. And the final velocity is how much? Final velocity is 0 meter per second. And the time taken for this whole thing is basically 10 seconds, because the 10 seconds is given over here. Now, what they are trying to tell us, that car has an acceleration of 1.5 meter per second square. That means 1.5 meter per second square. Okay, let's see. The A is equal to Vf minus Vi divided by T. Here's the formula. A is equal to Vf is how much? 0, minus Vi is how much? 15, divided by time, which is 10. So it is turned out to be minus 1.5 meter per second square. Now over here, minus signs over here, there is nothing over here, and they are saying about the acceleration. If they would have written deceleration, then we would have chosen this answer. But what they did basically was they changed the answer so that we have to choose a true answer. That means it is acceleration. Yes, it is acceleration. It is decreasing in velocity. The velocity is changing. The definition of acceleration said the rate of change of velocity, but it is decreasing. That is why we can't choose this answer. And there's an even better answer than this one. Moving on to the next answer, the car has a constant speed. Now, does the car has constant speed? The velocity of car over here was 15 meter per second, and over here it is 0 meter per second. So it isn't constant as well. So first two options, as you can see, is not right. Average speed of the car. What is the average speed of the car? It is 15 in the starting and 0 at the last divided by 2. So it is 15 divided by 2. It is going to be 7.5 meter per second. That is the average velocity of the car. So they have written 15. That is also not true. So the only option we have left now is basically the third option. The distance traveled by the car is 75 meters. But how can we prove it that it is true or not? By the help of formula. As you can see, this is a triangle, and the area under the line in the velocity time graph is basically represented by displacement. So S is over here, and this basically it is a shape of a triangle, and area of a triangle is equal to half into base into height. So we'll write down the area represents the displacement or the distance. S is equal to 1 over 2. Base is how much? Base is this much. So it is 10, and height is this much, 15. Multiply by 15. It will be equal to half into 150. So if we divide it to ones, 275 is a 150. So displacement or distance is equal to 75 meters. So this is our right answer. So we're choosing this answer. Distance traveled by the car is 75 meters. So removing all the drawings over here, we'll choose this option, distance traveled by the car. Moving on towards which one of the following graph are representing a uniform acceleration. Over here, again, there's a trick question, uniform acceleration. Now, I want you to understand the difference between these graphs. Uh, as you can see over here, there's a D over here. D is basically the distance time graph or displacement time graph. And it's like this. This is quite similar to the graph which I'm drawing over here right on the left side so that you can see it clearly, which is velocity time graph like this, which is the velocity time graph, and it is also in a straight line. So both of these graphs are looking the same, but there's a huge difference between these graphs. This line is basically showing the acceleration, whereas this line is representing the velocity. So they are not asking us for the velocity because they are asking us for the acceleration part. So this looks like a graph which is uniform velocity, but they are asking for the uniform acceleration. So we can't choose this graph right now because there's no D over here and there's no V over here, because this graph can't be right then. Now moving on towards the next graph. In this graph, this is a straight line, as we have shown over here. So this line will always show that the body is at rest if it is in between the distance time graph. But if it is in the form of velocity time graph, the same line will show that the body is moving with a uniform velocity. Over here, acceleration will be equal to 0. Now, moving on towards the part C or part D. First we'll do part D and then we'll move on to the part C, which says that, as you can see over here in part D, the line is curved like this. If the line is curved, then there's a velocity time graph as well. So that much we want, basically we want acceleration, and the acceleration can also be done in velocity time graph. But over here, the velocity is basically not constant. Okay, the velocity is changing, and it is not changing like a uniformly, or you can say like a uh, at any instant. It is changing with respect to time, but like this, that first the velocity was 0 over here, then it became suddenly at 50, meter per second, and then it became constant at 60. So it is not uniform, it is basically changing. So how can we represent it now? It is not uniform acceleration. The velocity is not changing constantly. It basically remains basically same for some time, then it changed. So this graph is also not the right answer. So the only graph which is left right now is C. Now how can we say that it is non-uniform acceleration? Now acceleration says that the definition of acceleration says that it is the rate of change of velocity, and the velocity is changing. The velocity, let's say it is 15 over here and 0 over here, the velocity is changing, but throughout it is changing constantly. And that is why we are choosing this graph, because the velocity is on the y-axis and the time is on the x-axis. So in this case, the velocity is uniformly basically showing us the acceleration in uniform uh, motion. That means acceleration is uniformly decreasing. So although we are using the acceleration in this case, but we know from the graph that it is deaccelerating, it is in negative acceleration. So here we have the answer, which is option C, and we are going to use the option which we know is C. And let's say that what is our answer and what is our score, and let's check it out. They say we have to traffic sign 1 2. Let's check our scores. Which one is the bicycle? Let's choose this one as well. Let's see our answer. Let's view the scores. Yes. So here's our answer. 100 answer, 100 out of 100. I hope you enjoyed the question answer session or MCQs. Inshallah, we meet again. Allah Hafiz.